Yeah, thank you for coming to my presentation. And I'm going to be looking at a case study where we look at overcoming some of the traditional limitations in using these AI technologies in a poultry processing workflow. So just a quick intro from FoodMate. We're founded in the Netherlands, but we're an international company with offices in the UK, the USA, Brazil, and Poland, but we serve customers across the globe. We're an engineering and manufacturing company, but we make equipment for poultry processing, specializing really in secondary process with applications through weighing, grading, distribution, and deboning. And yeah, so a little bit about me would be that I work with everything to do with vision, so anything to do with cameras, X-ray, they're the kind of technologies we use, and more we're looking at how can we use the information that we collect and with these sensors to make better decisions for our customers. So yeah, there's just you see a little bit of what we do. Okay, so that being said, there's a lot of automation already in poultry processing, but we also rely heavily on manual labor, and for very good reason, I think. If I was to say to you, could you please pick out this type of product from this other type of product? With a little bit of training, you can very quickly learn to do that and separate those things out. However, as the day goes on, perhaps you might get a bit tired of doing that, a bit more inconsistent. The efficiency of doing that task goes down. There's risks for becoming injured. They're very repetitive tasks, and it can be quite a hostile environment to work in. I would say, on the other hand, machinery is very good at doing those repetitive tasks. You can do the same cut over and over and over again. But what about when you then have a new product that you want to bring in, or something is different about the product that is coming in? How do you then explain to that machine, okay, well, actually, no, we actually want you to do this now? And for me, that's where things like AI are coming in more and more. So this is just one of our applications at FoodMate, where traditionally things like cutting and deboning were done by skilled butchers, and over time we're doing things in a more automated way. So we have grading systems where we take pictures of the product and we can say, okay, that bird's missing a wing, that's going to go here. There are blood spots, things like that. The customer can then choose, okay, what do we want to do with that product? And more we want to make more decisions like this through the workflows. So I think Riley set up what is AI quite well, but it is such a huge area of research that I think you do need to sort of think, well, what is it? And all of these technologies potentially have use in poultry processing, but today I'm going to be looking more at the computer vision side and deep learning. But it speaks to what I was saying before about a human can easily adapt to a new task, and how do we make that interface with machines? So yeah, stimulating human intelligence and problem-solving capabilities being the key part there, I think. So I've often seen AI also drawn out a little bit like this. So for me, machine learning is a subset of AI where we use data to make predictions, and over time, deep learning has come along where we can use more complex data sources like images. And so, yeah, in poultry, that's things like our automated inspection, sorting, grading, bringing in the computer vision side of things. And then, I'm not going to talk about robotics really, but then once we have all this data, can we then bring in robotics to be the final part of the puzzle in a lot of the tasks that we do? So today, in my talk, I want to really look at a case study, an example. Not a real example, but something where we've looked at using AI for one of our machines. So my sort of demo task here would be, okay, can I write an algorithm to segment the bone in this X-ray picture from one of our deboning machines? And so, yeah, you look at the picture and you can easily say, oh, yeah, the bone, that's those dark pixels across the middle. Yeah, I can see that that should be quite straightforward. So you set about writing that kind of algorithm. And then you find that, okay, someone's hung the product wrong on the machine and it looks a little bit different in that top picture. Or you find that an older group of birds is coming through and the calcification is different in the product, so your X-ray picture looks very different. Or there's something wrong with the machines further up in the pipeline and we're suddenly getting back attached. Or these are all things that we might want to actually flag, as well as being able to write a robust algorithm to do the demo task of segmenting the bone. And then you suddenly find, okay, it might actually take months to write an algorithm to take everything into account that we're actually trying to do here. So this picture is by NVIDIA, and I think it speaks a little bit to what Riley was saying before as well, that, we start with our data collection and data ingestion, but then the blue pit that I've labeled is the sort of validation, the labeling, the data preparation, making sure that data is right. And yeah, any PhD students that had to sit and label data will know that this is a very time-consuming and potentially expensive step in the terms of time it takes. For us, actually, we have quite a lot of data. We're processing maybe 6,000 birds an hour. We can collect thousands of samples very quickly. But in that bone segmentation picture, you're talking about labeling on a per pixel basis. Potentially very, very slow, lots of man hours involved in that. So in the sort of traditional AI approach, okay, maybe the trade-off with writing that conventional algorithm suddenly isn't that great. But because we have this huge access to data, is there a way of semi-automating the labeling process so that we can start to prototype and use these deep learning methods more quickly? So the model that I'm going to be looking at is by Meta AI, Facebook. It was released last summer. And they believe it to be a sort of ChatGPT moment for computer vision. It's a large model trained on 11 million images, 1.1 billion labels. And the idea being that instead of manually labeling all this data, can we use these modern networks to sort of streamline the process a little bit more? So this is some of the results from Meta. The paper's linked there for anyone who wants to look at that. But it's what they call zero-shot segmentation, so it's never seen this picture or this type of data before. It's able to do things like 500 segmentations very easily. And part of the interesting thing is it's also a prompt-based model, so you can potentially write a little bit, or you can click in the picture and say, okay, can you please segment that window there in that car? However, the execution time of something like this is in the order of seconds, and on our machines we need to be making decisions in milliseconds. So it's not on its own a solution, but it's a very interesting technology that's now out there for use. So in my kind of demo application here, I'm going to be looking at using the Segment Anything model to create our data set, our labeled data set for us, and then we're going to be then training another model which is more appropriate to our application, something that we can be a bit more lightweight and can run in our time constraints. So here are some of the examples for us using the Segment Anything model on our X-ray application. And you still need some, I would say, coding knowledge and things to get the best out of it at the moment, but using this pipeline, we generated 4,000 masks in these labels here that you can see in just a matter of hours. We could also do things quite easily, like say, okay, instead of just being background, foreground, we actually have the flesh, the drum, the thigh, all segmented separately, which we can do things with further down the line. We also found it to be quite flexible to some of those problem cases that we saw at the beginning. So yeah, the broken bone there, not a problem. I was able to not look at the back attach, but just the bone in that top picture. And again, when the product is hung wrong in the bottom picture, okay, we got that too. So the model in this application we used was UNet. It's a commonly used model for segmentation. It's from the University of Freiburg's research originally for biomedical applications, but what you need to know, I suppose, is that input, as it comes down the model, you have that X-ray image, and we're trying to abstract it to get the training mask, so that black and white image, and as it goes back up, that's what the output becomes. So when we then look at that, okay, yeah, we've managed to train the network, and here are some of our results. I would say that there are going to be, there's still further iterations on this, but the point being, we were very quickly able to use one of these, use a deep learning model in this application without, and cut down a lot of time that we would have needed, and we can now make decisions. Okay, is that bone intact, or can we cut here or here? So we can then use that to make a lot of decisions on our machines. I just wanted to go back quickly to the segment anything model and look at just a couple more things where we just put some data in to see how it worked. But this is some of our vision grading data. So you can see, it's nicely segmented the bird quite accurately in this case, and there's lots of potential applications for us for this. And also, if you think of like maybe robotic applications or some sort of, this is a pick and place type data input. So we've got all the thigh meat in a tray, and we say, okay, can we segment that? What does that look like? And I thought it was quite an interesting result, because there are some things that maybe I wouldn't have labeled in that way, where you can see the little pieces of debris are actually on top or on the tray. And so, maybe we should think about differently about how that would have been actually segmented if we were going to do it manually. So I thought that was quite interesting. And then maybe you train a model and look at a robotic solution for some kind of pick and place applications. But again, I think there's lots of potential there. But still, I think for us, some limitations around using these AI applications on our machines. The UNet model, the second model I looked at, is still 20 milliseconds on an i9 CPU. There are things I can do to bring that down, or you can use GPU, but for us, that adds hardware cost and potentially some back compatibility issues with the machines that are already out there. And then with the conventional approach, well, if something goes wrong, there's quite a lot of things I can do to tweak it for a customer, but then, so it can be a little bit of a black box, these models. Do I have to completely retrain from scratch? And things like the segment anything model make that a lot easier, but it still can be quite a long task. Same. But I think definitely lots of potential. Just to summarize, I think lots of potential opportunities out there for improving consistency in detection and reducing costs in poultry processing using these methods. The traditional methods can take a long time and may not always be robust. However, the AI approaches also tend to need a lot of data, and I think we've shown that we can overcome some of those limitations by looking at these more modern networks and integrating that into our pipeline. So quite a quick presentation from me today, but thank you for listening, and any questions, let me know.